4. Researchers find a creature from an alien planet. Its body temperature varies sinusoidally, so we can say it's either a sine or a cosine. That's what sinusoidally means. Reaches a high at 120 at 35 minutes. Reaches a low of 104 in 55 minutes. So I'm going to go up by 5s here. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, 100. I'll just go to 100 for now. And we know that we're going to go from a min of 104 to a max of 120. So D is going to be the average of those. 120 plus 104 divided by 2. You're going to get D is 112. That's the center line of your wave. The amplitude, or the A, is going to be the max minus D. So that's going to be 112 minus, 120 minus 112. So A is going to be 8. All right, so we know that our center line has to be at 112. I'm just going to put it right there. We have to go up by 8, so I'll go up by 2s, 114, 116, 118, 120, 110, 108, 106, 104. So our wave's going to oscillate between these two lines. And let's put the points on that we have. We have at 35, we're at 120. So put a point right here. At 55, we're at 104. So that means that that's half of a wave. So this difference in time, 55 minus 35 is 20. 20 is equal to half of a period. So the period is equal to 40. That means that B is equal to 2 pi over 40, or pi over 20. So if I was to write my equation, I would have f of x is equal to a, 8, and then we're going to write it as a cosine graph, and we'll find the phase shift in a minute. B is pi over 20. We're going to write x minus, and read our phase shift off the graph, plus 112. So now we need to read this phase shift. So we can take a look and say, well, since we know half of our period is 20, if we count out another 20, we'll be back at the top. If we count back another 20 from 35 down to 15, we'll be at a bottom. If we count back another 20 at -5, we would be at a top over here at -5. So our graph is going to look like this. Okay, and oscillate that way. So we have to pick our phase shift. So we can either phase shift this way to the -5 number, or we can phase shift onto our graph to the 35. So we're going to phase shift to the positive 35, and that's the equation of our graph. So if we plug that into the calculator, we've graphed it, we've wrote the expression for the temperature in terms of time, and then we want to know what was the time and what was the temperature when they first started timing. That means when x is 0, what was the y value? So we can do a calc value and plug in when x is 0. And then it says, find the first 3 times after they started timing in which the temperature was 114. So here's the 114 line. So we want this time, we want this time, and we want this time. That's when the temperature was 114. So we'll do an intersection. We'll put a second y equals 114 in, and we'll do calc intersect for that. So let's run through those very quickly here. I've already put my equation in. Okay, and I have made my window so that you can see the whole graph there, but I think I'm going to change it. Rather than go from 0 to 120, I'm just going to go from maybe 100 to 120, so that will zoom in on the graph a little better. So we'll go from 100, go from 0 to 200 in the time, and we'll go from 100 to 130, and then you'll be able to see the graph clearer. And while I'm in here, I'm going to put in my 114 temperature intersection line. Okay, so from 100 to 130, here's my graph. Looks a lot like the one that's on my graph paper. So I want to find out what's this value here. What temperature was it when we started timing? So we'll do a calc value. When x is 0, let's find the temperature.